For an operating system to manage processes, it has to have some kind of idea of what they're doing. If the operating system stops a process, it must know what it was doing when it was stopped so that it can restart it from the exact same point. So how does an operating system know what a process is doing? Let's think about the underlying hardware, the CPU, and think how it executes applications. Applications, before they can execute, their source code must be compiled and a binary is produced. The binary is a sequence of instructions, and they're not necessarily executed sequentially. There may be some jumps, loops, or even there may be interrupts that will interrupt the execution of the binary. At any given point of time, the CPU needs to know where in this instruction sequence the process currently is. So we call this the program counter, PC. The program counter is actually maintained on the CPU while the process is executing in a register, and there are other registers that are maintained on the CPU. These hold values necessary during the execution. They may have information like addresses for data, or they may have some status information that somehow affects the execution of the sequence. So these are also part of the state of the process. Another piece of state that defines what a process is doing is the process stack. And the top of the stack is defined by the stack pointer. We need to know the top of the stack because we said the stack exhibits this last in, first out behavior. So whatever item was the last one to come on top of the stack needs to be the very first item that we can retrieve from the stack. So the stack pointer maintains this information. And similarly, there are other bits and pieces of information that help the operating system know what a process is actually doing at a particular point of time. To maintain all of this useful information for every single process, the operating system maintains what we call a process control block, or a PCB.